Problem 7 has a barrel rolling along the ground. We want to determine this velocity here at the bottom of the hill such that the barrel will roll over the top of the hill with a speed of 2 feet per second at the top. And we're given the information that the barrel is basically a hollow cylinder, and I for a hollow cylinder is mr squared. Alright, so one of the things you may notice is you don't have any information about r. So as is the case in a lot of these types of problems, we will find that the radius does not matter. Likewise with the mass, we don't have a value for the mass. All that matters is the shape, and we're given that as hollow cylinder. Alright, so we're going to use conservation of energy. Conservation of energy, we always define a gravitational datum. We use that at the bottom. Okay, and so we have some initial kinetic energy, both rotational and translational, is going to be equal to some final kinetic energy plus some change in height, their potential gravitational energy. So there's our general equation. As I said, the kinetic energy is going to have two parts, translational and rotational. So let's write that out. 1/2 mass velocity squared plus 1/2 I omega squared, and both of those are initial ones, is equal to 1/2 mass final velocity squared plus 1/2 I omega final squared plus mgh. Okay. The other thing that we have to remember is the relationship between velocity, translational, and rotational. So we have velocity equals omega r. Okay. So let's go ahead and work symbolically one more step. We're going to have we want to find the initial velocity, so that's our unknown, 1/2 mv0 squared. 1/2 I is mr squared, and omega squared, let's solve this for omega. Omega squared is equal to v squared over r squared. Okay, so omega squared is v0 squared over r squared. That's going to be equal to 1/2 mass final velocity squared. We're given that value, so we can plug that number in. And this is going to be similar, 1/2 mr squared v final squared over r squared plus mgh. So there it is in symbolic terms. Okay, let's see what cancels out. Mass here, mass here, mass here, mass here, mass here, so that all cancels. It has to be in every term, so we divide through by mass. Okay, we have r squared here and r squared there, so that's how the r gets eliminated in those two terms. And we have numbers for everything else except for the initial velocity. So let's plug some numbers in. I'm going to go ahead and multiply through by 2. Okay, so that will cancel that half out, that half out, that half out, that half out, and put a 2 right there, just to save me a little time in my writing and calculations. So v0 is our initial velocity that we're solving for, plus v0 squared again. Okay, so that makes 2 of those. Just working through the algebra here, is equal to v final squared, which was 2 feet per second. Whoops, I messed that up. Yes, I did that right. Okay, these two combined, so here's my v final squared, which was 2 feet per second, plus, well, we got another v final squared there, so there's 2 of those. Okay, right here and right here. and 2 GH. So G, we're working 32.2 feet per second squared, and H of 3 feet. So all our terms have units of feet squared per second squared, and we can solve for V0 right here. Hope I've done this right. Alright, so looks like I can divide through by 2 in all of these. And so V squared is going to be 2 squared plus 32.2 times 3. That's almost too easy. And then the square root of that is 10.03. 10.03 feet squared per second squared. We took the square root of to get feet per second. So 10 or 10.0 feet per second is our velocity at the bottom to make it up the 3-foot hill.